Hey math students! Today's lesson we are reviewing the foundations of linear functions. So kind of going back to basics so that we really understand what is a line. We're going to start off with this warm-up, asking you to graph lines because I'm assuming you have some familiarity with it, and I want you to reach back in the depths of your brain to try these two problems. I do want to note when it says graph, those mean accurate graphs. There it is. Okay. Cool. So for the first one, it gives you 2 points. So I just plotted those 2 points. Right here is -3, 0, and here is 1, 4. And then I connected the line. As simple as that. For the second one, we were given an equation. And maybe you don't remember like this is the y-intercept and this is the slope. So some people maybe recognize that and said, oh, there's my y-intercept. So my y-intercept is 1 and then my slope is 2. So I go down 2 over 1, down 2 over 1. And it's as easy as that. If you didn't remember that, hopefully you remembered that anytime you have to graph something and you have an equation, and you don't know what it looks like, you can make a table. Anytime. If you have issues graphing, a table is your friend. So you choose the x values, you use the equation to find the y values, and you plot the points. So I plotted those 3 points to create my line. So that's it. Hopefully you were able to do those 2 things. Those are pretty basics of line. At this point, we're going to go into some definitions. So 1, slope. What is the slope? You've probably heard slope said a million times throughout your math career. And you've probably heard it being described as rise over run, or change in y and change in x. And that is very true, which is why I have this equation right here. So this is very important to know mathematically that the slope is the change in y over the change in x. But I also want you to have a conceptual idea of what that means. So that's why I have this written definition as well. So a slope is a number that describes both the direction and the steepness of the line. So both the direction and the steepness of a line. So in this warm-up problem, when I had a slope of -2, this -2 told me the direction, the negative told me that it was going down, and then the 2 told me the steepness. So 2 is a number bigger than 1, so it makes it a little steep, but it's not a very big number, so it's not very steep. But from that slope, I'm able to tell the direction and the steepness of the line. Okay. And then also in the written definition, it reminds us, that slope is calculated by finding the ratio of the vertical change to the horizontal change between 2 distinct points in the line. So vertical change and horizontal change, just a reminder, vertical change is the change in vertically x, and horizontal change is the change in y. So whenever you see that little triangle in any sort of formula, that just means change. And then this ratio is just saying it's the division. So ratio is a division or proportion between the two. Okay. So a reminder, there's slope. And then another aspect of linear functions I want to remind you of are the intercepts. So our x-intercept is a point on the graph that crosses the x-axis, but it's also when the dependent variable y is 0. Okay, so it's kind of 2 different things to remember about our x-intercept. It's where the graph crosses the x-axis, but it also means that the dependent variable y is 0. And then for our y-intercept, yes, it is true that a y-intercept is the point where the graph crosses the y-axis, but it's also important to know that it's the point on the graph where the independent variable x is 0. Okay, so those are 2 aspects that are important to remember about our intercepts. So make sure you have all of these notes written down about slope and intercepts, and then we're going to move on to some examples. Okay, so here's example 1. All of these examples are based around this graph on the right. So go ahead and take a second to look at the graph on the right and make sure you understand what it says. Okay. So first, part A wants us to find the slope of the line and describe its meaning in context. Okay, so we've got to find the slope and describe its meaning in context. So our slope is our change in y over change in x. So if we have a graph, it's pretty easy to find the slope. We'll just choose 2 points, and then we'll calculate the change in y and the change in x. So in this case, our change in y goes from 400 to 300, so that's negative 100. It's going down by 100, so it's negative 100. And then our change in x, this goes from 1 to 2. So that goes from 1 to 2, which is 1. Okay, so on a graph, it's pretty easy to find that. Or I could always just take my 2 points. So I have the point 1, 400, and I have the point 2, 300. And I could plug it into the equation. So y2 minus y1 over x2 minus x1. y2 is 400. y1 is 300. x2 is 2. x1 is 1. And then I have... Oh, did I mess that up? I did mess it up. Do you see my mistake? So if I said that 400 was y2, that means my x2 is 1. And if my 300 is y1, that means 2 is x1. So then when I plug in x2, I will say this is 1 minus 2. There we go. Thank you for finding my mistake for me. So 400 minus 300 is 100. 1 minus 2 is negative 1, which equals negative 100. I can squeeze it up here. Negative 100. So both ways, either looking at the graph or using my slope equation, I got negative 100 for the slope, right? Okay. So what does this mean in the context of the problem? So now I have to look at my units. So negative 100 over 1. Negative 100 represents the value of the washing machine in dollars. So that's negative $100 over time in years. So I'm going to summarize this in a sentence. I'm just describing it in context. So I'm going to say the value of the washing machine decreases, since it's a negative number, it decreases by $100 every year. So a slope of negative 100 in this context means that the value of the washing machine decreases by $100 every year. This is 100. There we go. Cool. Alright, now it wants me to find the x-intercept of the line and describe its context and meaning. So let's use color coding. So my x-intercept I will highlight in yellow. It's right here where we cross the x-axis. So I will say the x-intercept is equal to 5. Okay, the value of x is 5 at the intercept. And so what does this mean? So that represents 5 years, right? The x-intercept is representing 5 years, since that's the label on my x-axis. So what this means in the context of the problem is after 5 years, the washing machine has no value. Well, that's a little harsh. I'm going to say no, because you can probably still use it. It has no monetary value. Let's be specific. So it's worth $0 after 5 years. You can probably still use it to wash your clothes, but no one wants to buy it. According to this chart. Okay? And then let's find the y-intercept. We'll do that in green. So the y-intercept is right here. So the y-intercept, I'll just write y-int, that is 500. And that's $500. When t equals 0, the washing machine is worth $500. Or when we first buy the washing machine, the washing machine is worth $500. Yeah. Oh, I was gonna add a pretty picture here of my sunflowers. Oh well. So sunflowers are one of my favorite flowers. When I grew them this summer, I planted a little seedling that was 10 inches tall. The seedling grew 3 inches per week until it was 70 inches tall. It got tall. Okay, so first things first, we need to graph the growth of the sunflower from its planting to its peak growth. Include units on the axis and label any intercepts. So I'm going to let us both do this at the same time. And then we'll come back together and we'll compare graphs, okay? So you graph yours, you make your graph, and I'll make my graph, and then we'll compare, okay? Okay, here's my graph. Yours does not have to look exactly like mine. Maybe you used different units to show yours. I know that it's kind of hard if we don't have graph paper to like estimate where the points are gonna go. So I'm already looking at mine and I see it's not quite perfect. But the main points that I wanted to have on here was 0, 10, and then 20, 70. So those are some of the points. I guess I also have 10 and 40 right there. So I think as long as you have those points on there, no matter what units you used, that looks good. Some other important things to have is we should have our independent variable, the week since planting. We should have our dependent variable, which is the height of the sunflower in inches. So it's important to have those labels there. Okay? Let's see. Did we do all of part A? Graph the growth of the sunflower from its planting to its peak growth. Okay, so planting at 0, and then it grew all the way to 70 inches. Include units on the axis and label any intercepts. Okay, so we just want to include our intercept. Here's one right here. And I guess I already have it labeled 0, 10. Cool. So we did part A. Part B, how many weeks did it take my sunflower to grow so tall? So I already included a lot of information on my graph, and I did the mental math beforehand to figure out how to make my graph. And so I can see my sunflower peaked at 70 inches, and that took 20 weeks. So I can see that looking at the point 2070. So at 20 weeks, it was 70 inches. It's a long time. And then what is the domain and range of the sunflower graph? So my sunflower graph starts when it was planted and then stops when it reaches its peak growth, because that's what the direction said. So I'm graphing it from its planting to its peak growth. Okay, so this isn't an infinite graph. You may have noticed this is a little different from the warm-up. The warm-up, when I was graphing these lines, I drew arrows at the end, right? So when you graph a generic line, you want to have arrows at the end to show it goes on and on and on forever. That's important. But in this real-world situation, things don't go on forever. Same with the washing machine. Like this washing machine price graph didn't go on and on forever, because you can't have negative time, and a washing machine can't be worth negative money, right? So it has endpoints. And same thing with my graph right here. And so let's think about my domain. It starts at 0 and then goes all the way to 20. And this is my weeks. And then the range goes from 10 all the way to 70. That is in inches. And I use brackets because those weeks and inches are included. It grew all the way from 10 to 70 inches. There's a solid point at the end. Those are included in